Hello everyone, we are from Group 8. My name is Chu Jianwen and these are my group members.
Hi, today's presentation will help you to understand annual work analysis.
What is annual work analysis? To get a clear concept, let's look at its definition.
The definitions of the annual work analysis is the equivalence uniform annual work of all estimated receipts and disbursements during the life cycle of a project.
First objective of the annual work analysis is to define or convert money to equivalent annual cost and equivalent uniform annual benefit.
The second objective is to conduct annual work analysis to resolve a present cost to an annual cost.
The third objective is use EUAW, EUAC, and EUAB to compare alternatives by determining criteria.
Following that, the goal of annual work analysis is to convert an engineering economic analysis problem into its annual cash flow equivalent.
The advantages of annual work analysis is easy to understand, calculated for only one life cycle of project, which is useful for comparing projects of different duration. It's also used to rank alternatives according to their desirability.
The relationship between annual worth, present worth, and future worth are shown as below.
I'm going to start today by giving you a few tips on how to calculate annual cost. The first tip is when there are irregular cash disbursements over the analysis period, we use formula annual work equal to present work given A find PIN formula.
Second tip, when there is an initial disbursement or initial cost P followed by a salvage value F, EUAC can be found by three different formulas, where these three formulas will give you the same answer.
Tip 3. When there's an arithmetic gradient, EUAC computed by using arithmetic gradient uniform series factor, which is A over GIN.
Tip 4 is when there is direct relationship between present worth of cost or benefit and EUAC or EUAB. Below are the formula for EUAC and EUAB.
So let us go through the examples for calculating the annual cost. First thing we need to do is determine the cash flow estimate. In these questions, we know that the $1,000 was set as the initial investment P. The initial investment is the total first cost for the project. And the $200 was set as the service value S, since it is the estimate value of asset at the end of the project useful life. While A is the equivalent annual amount of cost that we need to calculate in this question. After finishing determining the cash flow estimate, we need to know which formula we need to use in these questions. Since there is an P and S, so the problem may be solved by these three different formulas. For the first method, it reflects the annual cost of the cash disbursements minus the annual benefit of the future sales value. For the second method, it computes the annual cost of the $800 decline in values during the 10 years, plus the interest on the $200 tied up in the furniture as the service value. And the last method computes the equivalent annual cost due to the unrecovered $800 when the furniture is sold, and it adds annual interest on the $1,000 investment. The I in these three equations is the annual interest rate, 7%, and the N is the period of the year. And one more thing, after finish calculate the annual cost, we can see that all these three calculations give the same result.
So, how do we analyze economic efficiency by comparing alternatives? The answer is by using the annual cash flow criteria. There are three criteria which are neither output nor input is fixed, fixed input and fixed output. For the neither output nor input is fixed, this is a typical and general situation, and the criterion is to maximize the equivalent uniform annual worth.
For the fixed input is the amount of money or other input resources is fixed. The criterion for this is to maximize the EUAB.
Next, for fixed output is fixed tasks, benefits, or other output to be accomplished. The criterion is to minimize the EUAC.
How to find annual worth? Let's see an example. In addition to the do-nothing alternative, three alternatives are being considered for improving the operation of an assembly line. Each of the alternatives have a 10 years life and a scrap value equals to 10% of its original cost. If I equal to 8%, which alternative should be adopted? Let's see what we have. The install cost is belong to cost, material and labor savings is benefits, operating expenses is cost, and scrap value is benefit. So our case is neither output or input fixed. Then we need to choose the maximum EUAW, where EUAW equals to EUAB minus EUAC.
For plan A, the EUAB is $14,104, while EUAC is $10,235. So EUAW is equal to $3,869.
And for the plan B, the EUAB we got is $9,172, while the EUAC we got is $9,725. Since EUAW is equal to EUAB minus EUAC, so the final EUAW we got is negative $553.
For plan C, to calculate the EUAW is use EUAB 14,228 minus EUAC 10,917, so will equals to 3,311, which is our EUAW. Above is the plan C cash flow diagram.
After the calculations, to maximize the EUAW, plan A is the best of the three alternatives since it has the biggest EUAW.
In conclusion, we need to resolve their consequence to the equivalent uniform annual worth to compare the alternative.
Thank you.